Okay, so today we're going to talk about solving polynomial equations. It's actually pretty simple. You guys should be very familiar with this whole thing. So the first thing that we want to do with these polynomial equations is set them equal to 0. Currently I have 9x to the third plus 18x squared equals 4x plus 8. And so with these equations, what you'll want to do is pass everything over to one side. So I'll get 9x to the third plus 18x squared minus 4x minus 8 is equal to 0. And now I must start checking my rational roots here. And so over here I'll write possible roots. And so the possible roots for this equation are 8/9. Whoa, we're going to have some weird ones here. The factors for 8 are 1, 2, and 4. The factors for 9, and 8 up there. The factors for 9 are 1, 3, and 9. And so I would write out my rational roots: 1 over 1, 2 over 1, so it's positive 1, negative 1, 4 over 1, and 8 over 1, and then again 2 over 3, 1 over 3, 2 over 3, and 4 over 3, and 8 over 3, right? But I'll write those out later. For now, I'll just go ahead and start checking the whole numbers here, because the whole numbers tend to get a little. They tend to. I can usually find one, and if I can find one, it's a third degree polynomial. Then I'm pretty much there. So let me just look. If I plug in a 1, I'm going to have a 9, an 18, a negative 4, and a negative 8. That's not going to equal 0, because 9 and 18 is much larger than 12. If I plug in a negative 1, negative 1 here, it does not look like that will equal 0. Let me try a 2. Remember, I'm just plugging in f of 2, right? So 9 times 2 to the third. I canceled out the 1s just by looking at it. Plus 18 times 2 squared minus 4 times 2 minus 8 is equal to, let's see, 9 times 8. 2 to the third is 8. 8 times 9 is 72. This is 4. 18 times 4 is also 72. Oh, this is not going to work at all. Minus 8 minus 8. This is not equal to 0. But it does tell me that negative 2 actually is looking like it's going to work. So I got 9 times negative 2 to the third plus 18 times negative 2 squared minus 4 times negative 2 minus 8 is equal to 72 minus 72 plus 8 minus 8, which is actually 0. Very nice. Okay, so what that means is I take my equation here. That means since f of negative 2 is a factor, is a root, that means x plus 2 is a factor of this. And don't forget to carry down the equals 0. Now that that's a factor of that, I can factor it out. Okay, so over here I will factor it out. I'm going to do not synthetic division. I'm going to go ahead and do long division to factor it out here today, because I know that people were having trouble with the long division, so this will be another example of long division. So x plus 2, and then I'll get 9x to the third plus 18x squared minus 4x minus 8. And so what do I multiply here to get an x? I'm going to multiply by a 9x squared. Let me zoom in on this little guy here a little bit. Okay, so the 9x squared times x is a 9x to the third. 9x squared times 2 is a 18x squared. Ooh, look at this. This one looks pretty fun. Now I subtract. If I subtract here, I get 0 and 0 here. Sorry, somebody's driving outside, so that's 0 and 0. What happens when you get two zeros? Well, oddly enough, you have to drop the next two things, okay? Because you got nothing left and you need 2. So that goes 0, and now we're going to go with this. And so what do I need to multiply the x by in order to get a negative 4x? It looks like I just need to multiply it by a negative 4. It's negative 4 times x is a negative 4x. And negative 4 times 2 is a negative 8. And sure enough, we do get the 0 that we need, because remember, if it's a 0, we should get a 0 as our remainder. And this right here is my other factor, 9x squared minus 4. So my other factor is 9x squared minus 4. And this actually looks like a difference of squares. So it turns out that this question is actually tremendously exciting, because it comes with all sorts of interesting little quirks. And so if I write this as 3x squared minus 4, now if I do the difference of squares here, this is going to be 3x. Oh, I'm not going to change. I should have changed that 4 to a 2 squared, because the factor is going to be a 3x minus 2 and a 3x plus 2. Look at that. So 3x minus 2, 3x plus 2. Why is that? Because, well, let me go over here. The difference of squares is like this. If I've got a squared minus b squared, it's actually equal to a minus b, a plus b factored. And so that's what I did here. My a is 3x, my b is actually 2. And so I get that. This is still equal to 0. And now to actually solve the equation, you use what's called the zero product property. This is quite possibly the greatest property of all time. And the zero product property says that if I have products that are multiplied together and they happen to equal 0, it turns out that solutions to this equation are where any one of the products are equal to 0. Because if this is equal to 0, then the whole thing is equal to 0. Or if this is equal to 0, then the whole thing. Or if this is equal to 0, then the whole thing is equal to 0. So I can say that x plus 2 is equal to 0. Or when 3x minus 2 is equal to 0. Or when 3x plus 2 is equal to 0. Okay? And so when any of these three, let me not make those arrows really. When either of these, this, or this, is equal to 0, then I have a solution. This one is pretty easy to find. The solution to this is x equals negative 2. The solution to this is add 2 and divide by 3. X equals, remember, add 2 and divide by 3, so that would be a positive 2/3. For this one, I would subtract 2 and divide by 3. Subtract 2 and divide by 3, so x would be equal to a negative 2/3. Alright? And so there actually is the solution to this polynomial. First what we did is checked for some rational roots. Then we did the factor theorem. We missed on a couple of them here. Then we finally got one that was equal to 0. Then once we realized negative 2 is equal to 0, then since the negative 2 is equal to 0, the x plus 2 is actually the factor. Then I needed to factor it out. I went ahead and used long division just for the fun of it. There were some interesting things going on in the long division. We ended up getting a 0, and then the factor we were left with is 9x squared minus 4. Place that here, and now to continue factoring, I use the difference of squares and the ever amazing zero product property. Okay, so this is factoring, solving polynomial equations.